Morning everyone, we are from Group 3 and the task we are doing today is on Jurong Lake Garden. I'm Yushin and my group members are Brian, Chloe, Evan and Yujian. The information given is that two people are walking at a different pace, one is slower and one is faster. They both start at the same point and walk together at the slower walker's pace until the slower walker wants to return to the starting point. The faster paced walker will then walk at his own pace for as far as possible. However, the faster walker will not want to make his companion wait for very long. We can find out how much time the faster walker can walk for before returning so that they can return to the starting point at the same time. The information we need to accomplish the task is where is the starting point, how far is the distance, the speed that the faster walker and slower walker is walking at, and the person that is walking. To solve the problem, we need to find the time that they walk together, and using that information, we can find the distance the slower walker returned to the starting point. We can use the timing to find out how far the faster walker can continue to walk, and then subtract the distance they walk together, which is x. Then we divide x by 2 to find the distance he travelled before he decided to return back to the starting point. Then we use his speed to find the time he needs to take to travel.
The solution we decided to do is solution 2 because we think this is the better solution. Now this is the explanation of the solution 2. Okay, so the faster walker will have to walk the extra distance. Wait, what? Wait, pause. Sorry about that. Mixed up. Okay, so first before solving the question, we must first make some simple assumptions. So the assumptions we made are the distance from starting point to end point is 5 km. The speed of the faster walker is 5.5 km while the speed of the slower walker is 4.3 km. Then we also assumed that both walker will go will speed race at 30 minutes into the walk. Assuming that they did not take any stop or rest, and we assume that both fast and slow walkers' speed are constant after they split. So 5.5 km per hour for the fast walker and 4.3 km per hour for the slow walker. And then we also assume that both walkers took the same route to back to the starting point. Okay, so the main formula for this solution is speed equals distance over time. So to find the distance before two walkers decided to split, we take 30 minutes because they walked for 30 minutes before they split. So 30 over 60 times the slow walker's speed. Then we get the distance which is 2.15 km. And since it took the slow walker 30 minutes to walk 2.15 km, it will take the same time to walk back given that they are traveling the slow walker is traveling in the constant speed. And then the fast walker will also need to return in 30 minutes because the question states that they they want to return at to the starting point at the same time. So then we use his speed to find the amount of distance he can cover in 30 minutes, which is 2.75 km. Next, the faster walker will have to walk the extra distance plus 2.515 km back to the starting point. So to find the extra distance, which is we define it as x, 2.75 minus 2.15 equals to 0.6 km. So to find the distance before he decides to turn back, we just divide x by 2 equals to 0.3 km. Now we have the distance, we substitute into his speed, and then we can find the time he take to travel 0.3 km, which is the time also he decided to turn back. So 3.27 minutes equals to 3 minutes 60 seconds. Okay. So here's the diagram of the of the solution.
So is solution 2 adequate? In our group opinion, we think is adequate. Is because in this solution we use time estimation instead of distance estimation, so we can gauge the distance more accurately because with the time we can roughly gauge the time using the we can roughly gauge the distance using the time as the time doesn't really affect the distance as much. If we want to make it more accurate next time, if we were to do this question, we can also use our phones at Jurong Lake to measure the distance to ensure that it's accurate, so that uh, the questions could be so the solution could be more adequate, even more adequate than it is already. So in both the solution, we have found a common formula. The formula is 60 half x divided by y. This is the formula to find the actual time the fast walker can walk before turning back. Where x we define it as the distance the fast walker can walk to return at the same time, the distance where both of them walk before splitting. And y is the speed we define as the speed of the fast walker. So how can our solution be extended to related problems in the real world? So it can be used when we go for outings and other exercises such as cycling, swimming, running, and many more. When one speed is faster than the other, and we want to find like how much time they can go further, how much time they can, what's the distance they can go more. This solution, therefore, this solution can be used in order not to waste time and allow the faster person to be more efficient, so they can catch up to the slower walker at the same pace.
The limitation in this strategy 1 and 2 is that they may convert units wrongly and there may be calculation errors. The diagram in slide 10 and 20 may be difficult to understand. The constraints are that the working it may be difficult to understand the working after they split, and one might be wrongly interpreted if they are working at different speeds.
So this is our group reflection from the 3 days of the math modeling. So for me, I learned that we have to thoroughly think deeper than the surface of the question, as the questions involve a lot of changes. So we cannot just look at the like they go here, distance here, but then we have to think that how does this factor affect the question and etc. Through this group project, I learned that a math problem, no matter how real the situation is, you will still need to make assumptions and introduce limitations to make the problem solvable. If not, it will not be solvable as too many aspects that that can vary.
I learned that we need to be open-minded as there are many possible ways to solve a question. I learned that teamwork is important in order to finish the project on time and come up with a solution that the whole group agrees on. Through this math project, I learned that math calculation in math can be used in real life, not just in math.
Finish recording ah? Oh yeah. Oh, you want to stop what? Can already eh? Yeah, we got stop. Pause already. Okay. Hey, give me. Now it's time for the proof. Pause lah.